Hi. Good morning. In this seminar, we are going to discuss about the TGA and the different types of TGA. First, we will see about the thermal analysis. Thermal analysis is a branch of material science and a group of analysis which study the property of the material when they change with temperature. In this technique, mass of the substance is a measure as a form of temperature while it is subjected to controlled temperature. The different types of thermal analysis include thermogravimetric analysis, which is abbreviated TG or TG, differential scanning calorimetry, DSC, derivative thermogravimetry, which is called DTG. Finally, differential thermal analysis, which is called TTA. Next, we'll see what is TGA. Thermogravimetry is a branch of thermal science which examines the mass change of the sample as a function of temperature in the scanning mode or as a function of time in the isothermal mode. Thermogravimetric analysis is a method of thermal analysis in which changes in physical and chemical properties of material are measured as a function of increasing temperature rate or as a function of time. Next, we will see the types of thermogravimetry. Thermogravimetry is classified into three types, namely isothermal thermogravimetry, quasi-static thermogravimetry, and dynamic thermogravimetry. First, we see the isothermal or static thermogravimetry. In this technique, the sample weight is recorded as a function of time at a constant temperature. Next, we will see the quasi-static thermogravimetry. In this technique, the sample is heated to constant weight at each of the series of increasing temperature. Next, we see the dynamic thermogravimetry. In this technique, a sample is heated in an environment whose temperature is changing in temperature manner, generally at linear rate. Next, we will see the principle of the thermogravimetric analysis. In thermogravimetric analysis, the mass of the substance is measured as a function of temperature. While it is subjected to controlled temperature program, the result is TG curve or thermogravimetric curve time. Temperature is plotted on x-axis or mass is plotted on y-axis. Temperature can be recorded from 0 degrees Celsius to 2000 degrees Celsius. The change in mass of our analytic is studied because of different physical or chemical transition. It is used in the analysis of volatile products, gaseous products lost during the reaction in the thermoplastic, thermosets, elastomers, films, fibers, paints, etc. The change in the weight of the substance is recorded as a function of temperature or time. The temperature is increased as a constant rate for known initial weight of the substance, and the changes in weight are recorded as a function of temperature at a different interval time. Next, we see types of transition using the TGA. There are two types of transition occurs: physical transition and chemical transition. In physical transition, the types are absorption, deabsorption, sublimation, evaporation, and vaporization. In chemical transition, types are oxidation, reduction, chemosorption, loss on drying, and degradation. Different types of graph obtained using DGR: desorption, absorption, polymer analyte, loss on draining, oxidation followed by decomposition. Next, we will see the components of instrumentation in TGR: recording balance, sample holder, furnace temperature programmer controller, and a recorder. The figure shows the corresponding block diagram of the thermobalance you used for the TG analysis. In the next PPT, we will detail about the components of the thermobalance. Thank you.